So, if we I have a couple of questions that are going to come from this, and we're going to solve two of them in this case. So the first question is there ever going to be a dimension where the radius of the central sphere is bigger than the radius of the corner spheres? So the radius of the spheres, when we take a cube and chop the box up into pieces, the radius of those is always a half, right?
Yes.
Okay. So is r greater than a half for some dimension?
Well, r being greater than a half. So, well, the first dimension that should happen would be for 5 dimensions, because for 4 dimensions you get root n is 2, so you get a half for the radius of your sphere.
Okay.
And so 5th dimension will be the first one where you exceed that.
Okay, and we can probably go real quickly. Oops, what did I do? On the calculator, we can probably compute the square root of 5 pretty fast. 5 square root minus 1 divided by 2. And sure enough.
Yep, 0.62 about.
Yeah, 6.8. That's actually related to the golden ratio. Interesting. Yeah, so the radius in 5 dimensions gets bigger than half. The next question is there ever a dimension where the radius is greater than 1?
Yes, there should be for 10 dimensions. So for the 9th dimension, your square root of n is 3, so you get 1 for your radius. So
okay.
That would mean the inner sphere is touching the sides of the box.
That seems strange to you?
Somewhat, yeah.
Why? Why does that seem strange?
Well, it seems like you won't, because it doesn't seem like the spheres on the sides will be able to sort of touch with this inner sphere being so big, because the inner sphere will be bigger than the outer spheres.
Yeah. So in 10 dimensions, that central sphere actually pokes outside of the box.
Yes.
Which is pretty strange. Right?
Yeah.
Yeah. And so now comes the strangest question of all, and we'll do it in the next video. But you can tell me what you think. Is there ever a dimension where the volume of the central sphere is actually bigger than the volume of the cube?
Well, yes, it does seem like there would be. Like, we could find that out using the volume of a sphere.
Okay. Alright, very good. That's what we're going to do in the next video.
Alright.